Welcome to this topic video on JavaScript Arrays. Simple functional programming with arrays. Our learning objectives are simple. We want to get more productive, meaning code quicker, easier, and with less errors. Okay. To do that, we're going to learn a bunch more about JavaScript array methods and a particular style of them, which is practical functional programming. Not obscure stuff, okay, but things that we'll see out in the wild, okay? I don't want you to be intimidated by JavaScript code you will see in the wild. In fact, we're going to come across some of these patterns when we're doing our React stuff, and there's some of the first code that you will see in the grown-up React tutorial on the React website. Okay. Reference. The JavaScript array reference page I visit all the time. My browser knows as soon as I start to type in MDN or whatever, it thinks I want to go to the array page. There's so much useful stuff in there. However, I don't remember it all. I don't even remember all the different functions and what they do. Okay? There's just so much useful stuff. What I'm going to be looking at is a certain class of array methods. Let's take a look at some of these. Sort. Sort takes a callback function, sorts the elements of an array. Can take a callback for custom sorting. Okay. Oh. For each executes a callback on every array item. Map callback returns a new array of the return value from executing callback on every array item. Filter returns a new array containing the items for which the callback returned true. Kind of filters down the existing array based on some function you give it. Every returns true if the callback returns true for every item. Returns true some if at least one item is true in the array according to the callback. Even more of these things. Reduce, callback, initial value. Wow, applies callback, blah, 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 blah. Reduce, right? Works like reduce, but blah, blah, blah. Wow. Well, if in class we would take a poll. What did the previous set of array methods have in common? Well, it seemed like, Professor, they all have their first parameter in common. And their first parameter is a function, a callback function. Yes, they all take callback functions. Okay. What are we trying to avoid? Useless loops. Okay. We don't want to write loops. Now, what's a useless loop? A useless loop is a loop that doesn't work. I'm not saying you'll never use a for loop again. However, we want to avoid broken loops. Okay? Avoid writing loops for common operations. The idea is let the array do its own iteration rather than you writing a loop. Okay? This is, and I'm going to sneak it in here, because all these functions take a function, this is a form of functional programming. Very practical functional programming. Okay, so let's see how these things work. Okay, map. Map produces a new array by running a value on each element of the original array. Let's take an example. Okay. What's this? My strings. Okay, it's an array full of strings. This is a sentence, this is a second sentence, this is a third sentence, etc. So this is an array full of strings. Okay. I'm going to run map on this. Here's map. Ooh, I define a function in here. Okay. Ooh, I directly define the function. I didn't even pull it out. Am I allowed to do that? Let's see. Let's copy it. So the objective here is to wrap a bunch of text in HTML tags. Let's see if this will work. Let me clear that up. Okay, so we want to see what we get at the end. My P. So we're starting with a bunch of strings. We want to produce a bunch of paragraphs. Okay. Where's the outputs? Oh, this is a sentence. This is a second sentence. This is a third sentence, and so on. So we got a new array from the old array, but every item is now wrapped in P's for like paragraph tags for use in HTML. You think this is a way that we could transform some data into a bunch of HTML for showing it on the page? Yeah, might be, Professor. Now, one thing might be bugging you. We define this function, this little function in here. This is known as an anonymous function, but I could make a real function. I could say function, I'm a real function, my function, and it's going to take a parameter s, okay, and it's going to return, I'm going to steal a little bit of this, return a little bit of code here. Let's take that so I don't retype it out, because otherwise you'll have to watch me retype it out. So I got to come in here, put that function in there. Okay, it's going to return that thing. So that's my new function. So with this function, I can even test it. My func hi class. Oh. So this function, all it does is just wraps up some text in the function. Now, let's try my s's dot map. What did we call it? My function. Oh, we could do it this way. Okay. Professor, why did you do it this way up here and this way down here? The reason why I do this form, which is called anonymous functions, is look how short this function is. There's one shorter way of defining a function that we'll do a little later on called arrow function. Okay, but this is a very short little function. I only use it once. It doesn't make sense to give it a name. Okay, if this function was getting complicated, I would pull it out like I did here and test it separately. Okay, just how I would do that. If it's a simple little one, thing, I only use it once. I use this anonymous function because I'm never going to use it again. I just use it here. Okay. Otherwise, I will create a separate function. But these two, the end effect is the same. I run a function on every element of the array, and that produces a new array. Map. Nice. Okay. Did we have to say iterate over everything? No, we didn't. Do we have to use a for loop? No, we didn't. Professor, what if I need to keep track of which element I'm in the array and such like that? Oh, mean like, say we wanted to produce a bunch of paragraphs and put a little indication of which number that paragraph is out of whatever? Ooh. So additional parameters that this function can take are the current index, as if we were using a for loop, and we can give it the total array. Okay, so this is being called on an array, And we can get, though, inside our function, our callback, the whole array if we wanted it. Okay, so here's an example. Again, we have it with the strings, a bunch of strings, but this time the function's not just taking the current value in the array, it's taking the index in the array itself. What is it going to produce? It's going to say, what is this? What is this thing? It's a backtick string. Okay, getting a little bit more complicated because we got more stuff to do in here. Last time I used the plus for string concatenation. Now I'm using a template string. Okay, I put in my P. This is where we get substitution. I substitute I, which goes from 0 to the length of the array minus 1. So instead I go I plus 1 out of the array length. Oh, so I use the entire array so I can get the array length. Let's try this. Because you know, in a lot of types of documents and situations, you want to know how many out of such and such. Okay, this is a way to do it. Okay, paste. Array. The result is P, 1 out of 3. This is a sentence. Paragraph, 2 out of 3. Another sentence. Paragraph, 3 out of 3. You think we're going to be using this stuff to format some data? Yeah. Professor, you haven't even talked to us about HTML tables. Why is that? Because we're never going to do an HTML table, even in an example by hand. It's too tedious. We are going to use methods like this to help us construct tables. Okay, we're going to start with raw data, and we're going to use JavaScript code, map, okay, or other methods to help us come up with, go from data to HTML, especially for tables. Tables got a bunch of structure to them, and they're tedious to do by hand, right? We're trying to avoid tediousness. So cool. We can get the index, nice, and we can have the total array available if we need it. If we don't need it, we don't have to use it. Okay. Okay. And that's available to map and others of these. Let's try another one of these. Filter produces a new array containing only those elements that meet the criteria of the callback function. Filter. Okay, this is a little artificial, but not too much. Okay, I just wanted it easy for short code. Okay, I'm going to have a rand array, so I declare an empty array. Here, I actually need to use traditional array stuff because I need to call math random a bunch of times. Each time it's going to produce a new random number. Okay, so I got to push these random values. It's going to give me random values between 0 and 99. Well, actually, this will give me random values on 99.99999. I didn't do any truncation. These are going to be floating point. So I filled the array with 20 random values. Then I say random values less than 50. Ran array filter function return. So this is going to return true or false. Okay, so I'm defining one of these anonymous functions again. Function x returns true or false. X less than 50. So if x is less than 50, that item will be put in this new array. Items greater than 50 will not. Okay. Here we're going to take a look, do that, the opposite test. We're going to filter out those that are less than 50. Let's give this a shot, see how it works. And let's clean that up. Okay, rand array. So we're going to first, let's do this in parts. Let's create a random array. What does it look like? Rand array. It's got all these random values in it. Okay. that out. Let's see if we can get all the elements that are less than 50. Array. It's only got 8 members in it. 48, 42, blah, 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 blah. It looks like it worked. Okay. Doesn't seem like a great random number generator. Let's try the next one. Let's try greater than 50. An array of, oh, actually this isn't so bad. Why did I think we were making 100 values? We only made 20 values. Okay, 95, 52. Easy peasy. Okay, the way to separate things. This is how you may separate. You may get a bunch of data. You may need to separate it in separate groups because you're going to display it differently. Okay. Filter. Filter also gets those other parameters. It gets the index and it gets the total array. I just didn't show it. Okay. I'm sorry, this one's going to be a bit annoying, but you don't have to run it yourself if you don't want it. Here is my array. Hi. Hello. Hello. Wake up. Yes. Okay. Here, we don't produce any output. We do something with each element of the array. Okay. We don't produce a new array. We just go do something with the array. Okay. So, what am I going to do? This is a real annoying function called alert. So let's copy it. Let's run it. Hi, it stops everything. This is an old-fashioned little feature that's got left in the browser from the old days of the web. Oh, it knows this is so annoying that my browser asks me if I want to prevent this from popping up more of these dialogues. Okay, so now it says hello. Now it says hello with double exclamation marks. Then it screams wake up at me. Okay, so we use for each when we want to do something, but we don't need a new array. Okay, map produced an array the same size as our previous array. Okay, by running a function on it. Filter produced a new array that could be much different in size because it only took those things that satisfied a criteria. For each does not produce another array, it just does something with each element. Okay, as we saw here, no new array was created. Every. Okay. Every. What does it do? It tells you if every item in the array meets a check. Okay. So here we have this function. It's like filtered, but not quite. Same kind of function. Actually, these are the same. It's very similar functions like we used in our filter example, except it's not producing an array. It's just going to tell me, did all the data meet a particular criteria? Did all the elements of the array meet a criteria? So let's check it out. Copy. Okay, so we have to check a bunch of data to see if something's valid for everything in the array. Okay. Let's do it once again, the way we did it before. Okay, we produced a random array of values, okay, between 0 and 100. Okay. Now, we're going to run all less than 50. What do you think the answer is going to be? False. We can see there's things greater than 50 in here. Sounds good. That was nice. Didn't take hardly any coding on our part. Didn't matter how long. Did we have to say let I equals such and such and such and such? Did we have to keep track of things and AND them all together to see what the result is? No. Does this thing know that once it sees a value that doesn't meet the criteria to stop? Yes. Very efficient. Okay. You're not going to be able to write something more efficient than what's in these built-in methods. Okay. Let's try all less than 100. Oh, well, of course, because math random is between 0 and strictly less than 1, so we can never produce 1, so all the values were less than 100. Nice. Okay. Sum works in a similar way. Okay. It just says, do any of these things meet this criteria? Then it's true. Okay. Some examples. Okay, we already have the array. Copy. Sum. It's a new array. Let's just double check it. Rand array. Full of random values. Now, are some of these things less than 50? So we say random array, sum, function. So are any of these things less than 50? The answer should be true. Makes sense. Are some of these things greater than 100? Or another way to say it, are any of these things greater than 100? False. No, because we designed it that way. Okay. So great for checking all the values in the data set quickly and easily. Okay. Don't reinvent the wheel. Okay. Reduce. Come up with a single thing by iterating over an array. Here's a string. Here's a string. Even more, here's an array full of strings. This thing takes an accumulator. 3 items this function takes. An accumulator, the current item, can take the index and the entire array. It also, look over here, reduce. It takes this function, but then it also takes this other parameter. This is the initial parameter that goes into this accumulator. This function is going to return, okay, the value that this function returns goes into the accumulator for each iteration. Okay, it sounds clear as mud, Professor. First, let's see if it works. Okay, and what's it going to produce? Oh, look at this. It produced a string, one single string, with all these paragraphs together like we defined last time. Nifty. So it put everything together. Okay, so we didn't have to do anything more. Sorry about that. Professor, that seemed a little too quick for me. You got another example? Glad you asked that. Yes, I have another example of array reduce. Okay, this is a simple but not trivial example. Neither was the other trivial example. It's just we went quick. Okay, here we're going to show you some sales data. Okay, we have an array full of JavaScript objects. Oh, that's scary. It's not scary. It's not scary. I swear. Let's go. Put it into, okay, simple. Okay, we got an array of JavaScript objects. So let's copy this. And I'm going to clean up our mess. Okay, we get a lot of data this way. Okay, sales data. Sales. Item 0. Customer Kevin, amount $11.95. Okay. Now, each element of this array is just an object, right? So that means we can go customer, and we can get the amount. We can go sales 3, and we can go dot amount. What we can't do is there's no magic function that's going to allow us to just add up all the oh wait, I think there is a magic function that'll help us add up all the amounts. We just have to learn how to use it. Isn't that reduce kind of with accumulation and stuff? Let's go back to the example and take a look. Okay, suppose we want the sales total from this array. To use the reduce array method, we need to define two things: an initial value for the accumulator, and a function that takes the accumulator value and the current value of the array and produces a new value. Okay, so here's my example function: accumulator array element. What's it going to do? It's going to take the value in the accumulator and add the array element dot amount to it. Oh. That's okay. So this is a more complicated situation, hence why I'm defining the function outside. You could define it inside, but let's just take it out and play with it a little bit. Okay. The examples we go through quickly because you have limited time. When I write them, though, I take my time because it takes time to write these things. You learn things by slowing down. So how could we do this? Sum sales. Let's say we gave it an initial value of 100. Okay. Now we need to give it a value for the array element. Okay. Typical array element looks like customer, Greg, okay, or Dr. B, and we get an amount $3.65. Wow, without even me hitting return, it's showing me the value there. So it took the accumulator value, I gave it a sample of what my array element could look like. That's not an element, anything that's in here, but it's got the same form. Because what's this going to be looking for? It's just going to be looking to see that the array element has a field amount. What if it doesn't? Oh, I guess we could use a filter method to filter that out so things don't break. Okay, but that's another story. Okay, so now I've tried my sum. Okay, now what's the next step? Oh, we're going to run the reduce function. Okay, so let's take a look. Go back to the example, because not that example, this example. Okay, we're going to run, okay, the reduce method. Now it looks a lot clearer when we write it this way: sales.reduce sum sales and the initial value. Why are we giving it 0 as the initial value? Because we're assuming that this is all the sales for the day. We could give it another initial value if we already had booked some sales. Let's try it out. Okay, so we're going to go sales.reduce. What do we give it? The reducing function, sum sales, right? Okay. And then we're going to give it the initial value. Oh my gosh. These guys know how to evaluate this function so quickly that I don't even have to hit return. If our sales were up from the previous time period were $1,000.10, okay, and we wanted to just add in the sales that from this most recent time, we could do it this way. Hence why the accumulator is a separate value. So that's another example of reduce. Okay. Why did we need it? Well, we had the sales data, but it wasn't simple. We couldn't just say sum. There's no command to just sum the array, okay? Because the array doesn't make sense to sum because it's not an array of a bunch of numbers. It's an array of objects of which we are interested in one field. Notice, though, with just a little work, we were able to come up with a sum sales that extracted the sales amount from each one of these things and added them together, okay? You're going, Professor, that seems like a lot of work. Well, compare it to what you would do by hand to do the same thing, and also how you can make this very clear. This is sum sales. What if we wanted to list customer, get a list of all the customer names? We could do another thing that gave us that produced a paragraph of all the customer names like we saw in the previous example and put it into a special format if we wanted. Okay? So, our goal is to avoid useless loops, avoid useless loop road, which I mean is broken loops, and be efficient. Don't reinvent the wheel, because by the time you do, you've got a chance that you've increased the chances that your code is going to have errors. By using these standard methods, okay, you also increase readability, okay, and reduce your time, because to make the same thing as reduce yourself and to make it readable, you have to add a bunch of documentation to it. Okay, cool. Remember, avoid useless loops.